Okay, now in this question, uh, they give you another parametric curve where x is related to t, y is related to t, and they want the length of the curve. The equation for the length of the curve is this. The derivative of this you square, and the derivative of this square under the square root. So if I go here, find the derivative of this, it would be 6t. And if I find the derivative for x, it would be 3 minus 3t squared. So we're going from 0 to 1. The derivative squared and the derivative squared. And dt outside. Now squaring this is 36t squared. 3 squared is 9. And then you multiply this by 2. You get 18t squared. And you square this, you get 94 dt. So you go from 0 to 1. I'll start from the highest exponent, t4, and then this minus this will give me 18 t squared plus 9 dt. Now, usually, this, when you do a question like this, when you see this, it's usually what's called a complete square. Meaning that this, you can write as, you take the square root of this, and the square root of this squared. If you expand this, you'll see that it will match this. So usually you'll end up with what's called a complete square, where you square root the first one and the last term, you add them, you square. And the square root and the square, they cancel each other. You have this left. And that would be 3 and 3t, 0, 1. 1 will give you 1 plus 3, and 0 will be 0, so the answer is 4. Now, to stay with the parametric, I'm also going to look at the other workshop, the 1B, and see if I can answer the parametric questions, the ones that are different. Now, and the other one, 1B, the first question was to sketch the curve again by elimination. And yeah, so you got question 1, workshop 2. You have x equals cosine squared and y equals cosine t. So to actually sketch this curve, you'll see that if I square this, I get y squared equals cosine squared. Then instead of cosine squared, I can say x equals y squared. Now, when you sketch this curve, now it's very known that y equals x squared will look like this. And negative will go down. This is the same idea. It would be like this. But the problem is, since your x is cosine squared, that means cosine squared is only between 0 and 1. So your x is only between 0 and 1. So you don't actually need all of this part of the curve. You only need the part that gets you to the 1. And cosine by itself is between -1 and 1, but that's fine. So this point is -1, 1, so you only need this portion of the curve. The other question, B, in workshop 2, was to sketch this curve. X equals root t, and y equals 3t minus 2. Again, you notice here that if I square, it would be x squared equals t, so I can replace the t here by x squared. Now, this is the normal x squared. Minus 2 will make it start from minus 2. Now the question is, do we need the entire curve? Do we need part of the curve? You'll see that x is root t, meaning positive root t. So x is only positive. So you don't need this section of the curve. So you only need the section that goes like this. And for the y, there is no limit for the y, so this is the part of the curve needed. Now, I'll go, let me see. Yeah, there's another good question for the parametric. We'll do that. Question 2 is a good question. Question 2 in workshop, you have x equals a bracket cosine plus theta sine theta, and y equals a also, sorry, sine theta minus theta cosine theta, theta between 0 pi over 2. So I told you what the equation is. You need the derivative for this. Now a is a constant. You can take it inside. So if you take it inside, this would be a cosine theta, and the derivative of a cosine theta, let me write it this way to be clear. If I take the a inside, it would be a cosine theta, a theta sine theta. And for the y would be a sine theta minus a sine theta cosine theta. So now we do the dx over dt. Derivative of this minus a sine theta. Here we need to do the product rule. Derivative of a theta is a times the second one. Derivative of the second one is cosine times the first one. Then we do dy over dt. Derivative of this would be a cosine theta, and the derivative of this product rule. Derivative of the first one is minus a times cosine, and derivative of cosine is minus sine times minus a theta. I'm going to erase this. Now, you look at this to see if you can cancel anything. You'll see that this term and this term, they cancel each other. Looking at this, you'll see that this and this cancel each other, and negative times negative is positive. So I can write this as a theta. I'll put this first, and it's positive because negative times negative sine theta. And here the same thing. I put a theta first, cosine theta. Length of the curve, AB, square root derivative squared, derivative squared. They tell you it's 0 pi over 2. You square this one, a theta cosine theta squared a theta sine theta squared d theta. 0 pi over 2. You square this, it would be a squared theta squared cosine squared. You square this, it would be a squared theta squared sine squared. Zero pi over 2. If I take a squared theta squared common factor, I'll have cosine squared plus sine squared left. And you know that cosine squared plus sine squared is 1. So you basically have a squared theta squared under the square root, and the square root of this is a theta. So that's what you're actually integrating, and the integral would be 2 over 2. You plug 0 and pi over 2, so it would be pi over 2 squared over 2 minus 0. That's the answer. And if you want to write it in a good way, that would be a pi squared over 8. This is the end of the second part. Now, for the third part, we'll continue with worksheet 1A and B. I'm going to do the polar system.